Welcome to our channel Circuits Analytica. In this video, we will discuss RC low pass filter. A simple RC low pass filter consists of resistance R and capacitor C. Output voltage of the circuit is taken across the capacitor C. Capacitive reactance Xc is given as Xc is equal to 1 by 2 pi Fc. When F is equal to 0, Xc is equal to infinity. That means for DC signals, capacitive reactance Xc is equal to infinity. When F is very low, Xc is very high. And when F is very high, Xc is very low, where F is the frequency of the input signal. Now let us discuss the working of RC low pass filter when input signal is a DC signal or when frequency of the input signal is equal to 0. When a DC signal is applied as the input, capacitive reactance Xc is given as Xc is equal to 1 by 2 pi Fc. So capacitive reactance Xc is equal to infinity. So current flow through the circuit is given as I is equal to V in divided by R minus J Xc. As capacitive reactance Xc is equal to infinity, denominator of the above equation becomes infinite. That means current flow through the circuit I is equal to 0. When current flow through the circuit I is equal to 0, voltage drop across resistance R, VR is equal to I into R, that is equal to 0. When voltage drop across resistance R is equal to 0, output voltage V0 is equal to V in minus VR. That means output voltage V0 is equal to V in. So when a DC signal is applied, output voltage V0 is equal to input voltage V in. Next, let us discuss the working of RC low pass filter when frequency of the input signal is very small, say 1 or 2 Hz. When frequency of the input signal is very small, capacitive reactance Xc is very high. As capacitive reactance Xc is very high, current I is negligible, as current I is equal to V in divided by R minus Jxc. So this time denominator is very high. It's not infinite, it is very high. So I is equal to V in divided by a very high denominator. So I is negligible. As I is negligible, voltage drop across resistance R, VR is equal to 0. As VR is equal to 0, output voltage V0 is approximately equal to V in. Output voltage V0 is approximately equal to V in. Now let us discuss the operation of RC low pass filter. When frequency of the input signal is in the mid-ranges, when frequency of the input signal is in the mid-ranges or moderate, Capacitive reactance Xc is moderate. So due to voltage drop across resistance R, output voltage V0 will be less than Vin. So here we can see that when frequency of the input signal rises gradually, capacitive reactance Xc falls. So current starts to flow through the circuit. I is equal to Vin divided by R minus JSC starts to increase. So gradually voltage starts to drop across resistance R. So gradually voltage across the capacitive reactance starts to fall. At very high frequency of the input signal, capacitive reactance Xc is almost equal to 0. When frequency of the input signal is very high, capacitive reactance Xc is very small. So current I is equal to V divided by R. So actually current I is equal to V divided by R minus JXc. As Xc is approximately equal to 0, current I is equal to V divided by R. So voltage drop across resistance R is given as VR is equal to I into R. That means V in by R into R. So VR is equal to V in. As VR is equal to V in, output voltage V0 is equal to 0. Capacitive reactance Xc is equal to 0. Output of the circuit is shorted. We can see that output is pulled down through the capacitive reactance Xc. So output voltage V0 is equal to 0. Thanks for watching Circuits Analytica. Enjoy learning.